Okay, today we're looking at numbers in scientific notation, which maybe you've seen in a science class before. And our first sentence here on our notes shows us what this definition is. A number in the form a times 10 to the n, where n is an integer and 1 is less than or equal to absolute value of a is less than 10. Here's what this means. So there's going to be a number in front times 10 and then a number for the exponent. The number in front is between 1 and 10. It's allowed to be 1, it's not allowed to be 10. The exponent is an integer, so it can be positive or negative, but it has to be a whole number. It can't have decimals in the exponent. So we're trying to get every number to look like this. Our example number 1 right below it shows how you can take a regular number that's in standard form and change it to, it's the opposite. Take a number that's in scientific notation and put it back into standard form, which means regular. So this number 5.59 times 10 to the 6. The 6 tells us that they've moved the decimal point 6 times. And the positive 6 means that we should get a large number for our answer. So over here on the side, I'm going to write down that a positive exponent means a large number. Positive exponent means a large number. So then they took the decimal point, which used to be here, moved it 1, 2, 3, 4, 5, 6 times. Now it ends up back here. So all of these little swoops that didn't have any number after the 5 and the 9, they put zeros in to fill them in. So the answer would be 5,590,000 for regular standard form. Then example 2 does the opposite. It takes a number that is already regular in standard form and wants us to write it in scientific notation. So in scientific notation, we're supposed to have the number be between 1 and 10. That's why they're taking this decimal point and deciding that they want to move it here behind the 3 because it would make it say 3.18, which is between 1 and 10. So to do that, they're moving it. Let's see, they moved it 1, 2, 3, 4, 5 times to get it there, which is why their exponent is -5. It's a 5 because they moved it 5 times. It's a -5 because the number that they started with over here is a very small number. So I'm going to write down over here on the side that a negative exponent means a small number. So that's been one example of moving it back and forth. We're going to try some on our own. When we do, this paragraph underneath here is saying please keep any digits that they give us. So we're not going to really round. We're going to keep all of the decimal points that they've given us. So example 1 says to determine if these are in scientific notation or not. Well, the first one's definitely not because 45 is not between 1 and 10, so it's not. The second one looks like it is. 2.35 is between 1 and 10. There's an integer for the exponent, -4, so that's good. Nope for the third one. Also because this number, 10.7, is bigger than 10. Fourth one looks okay. It is in scientific notation. So now we get to convert some of our own. We have a regular looking number and we need to make it in scientific notation. So I am supposed to put the decimal point where it's making a number between 1 and 10. Problem is with A, I can't tell where the decimal point is. If you do not see it, it's at the end. So it starts here at the end, and since I want to make a number between 1 and 10, it needs to go here. So it says 2.3. So I need to count how many spaces to move it. 1, 2, 3, 4, 5, 6, 7. So my answer is going to be 2.3, and I'm not supposed to round, so I'm going to keep all these digits after because they aren't zeros, so that means they matter, times 10. And since I moved this 7 times, the exponent is 7. Since it's a very large number, it's bigger than 1, it stays a positive 7. So this would be my answer. For the one that's right next to it, same thing. I see the decimal point this time. To make it be between 1 and 10, it should go right here. And so let's count how many times that moves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would say 4.57 times 10. It's always times 10. And then the exponent, we moved it 10 times. And since it's a teeny tiny number, smaller than 1, it's going to be times 10 to the negative 10. The next examples, we get to look at numbers in scientific notation and change them to regular form. So I'm going to write this one down again, 2.13. This 5 tells me that I should move the decimal 5 times and make it big. So that means I'm going to move it to the right. So I'm going to take this decimal point and move it 1, 2, 3, 4, 5 times. Now when I look at this, 2 of my little swoops already have numbers in them, a 1 and a 3. 3 of them do not. Those I need to fill in with zeros. So I'm going to actually write that over here too, that I'm going to fill in spaces that I create when I'm moving with zeros. So my answer for letter A here would be 213,000 or 213,000. Okay, let's look at letter B. Letter B, I have 9.65, and I'm supposed to move this decimal place 4 times to make the number smaller, so to the left. 1, 2, 3, 4. Again, one of the swoops is filled in with a 9, but the other ones need zeros, so my answer is going to look like 0.00965 with the decimal in front. And that is how I'm converting scientific notation to and from. On the back, it says the Earth is approximately 93 million miles from the sun. How would you represent this in scientific notation? Well, the decimal point starts on the end, and I'm supposed to make a number between 1 and 10 for scientific notation, so it should go between the 9 and the 3. Then it would say 9.3 times 10, and I don't know what the exponent is. Let me count how many times I'd have to move that dot. 1, 2, 3, 4, 5, 6, 7. So my answer would be 9.3 times 10 to the 7 miles is how far we are from the sun. Now, in our calculator, scientific notation looks a little bit different. You've probably seen it this year at some point, on accident maybe, but for example, if you multiply 225,000 and 2 million in our calculator, your answer will be 4.5E11. What this means is 4.5 times 10 to the 11th power. So the E stands for scientific notation, but I like to think of the E as the exponent because it gave us the exponent 11 for the scientific notation answer. So then the next one, if you divide 0.5 by 2 million using our calculator and push enter, you get 2.5e negative 7. That would mean 2.5 times 10, and the exponent is negative 7. The way that you can type scientific notation into your calculator is you'll see the button that says EE and it's in blue above the comma. So you have to push the second button and then the comma button. And it would type, even though it says EE, it only types in one E. So why don't you practice typing in 2 times 10 to the 4th? And when you type it in, it should look like 2E4 when you use the second button and the comma to make it look like that. If you want, you can push enter and hopefully it will tell you that the answer to this is let's see, 1, 2, 3, 1, 2, 3, 20,000. There we go.